In this video, we'll talk about vectors in R3. So if you have C to be a scalar, a constant, and U written in the form U1, U2, U3, and V1, V2, V3, if you want to add the vectors, you add them component-wise. So you add the U1 with V1, U2, the numbers on the second position together, and the ones on the third position together. If you want to subtract them, you subtract the first ones, U1 minus V1, U2 minus V2, U3 minus V3, and if you have to multiply by the scalar, you multiply each component. So knowing this, let's solve a few problems. Let's say U equals 2, negative 4, 1, and we want to find 1/2 U. So let's keep in mind that the vectors have to have the arrows on top. They usually, in the book, they usually write them as like thicker U and V, but just so that we emphasize that it's a vector, let's put the arrow in. So we will have to multiply 1/2 with each component. So we get 1, negative 2, and 1/2. It's half of the vector U. Negative 2V means negative 2 times 3, 0, negative 1. So we have negative 6, 0, and 2. U plus 2V, so we have 2, negative 4, 1, plus 2 times V, which is 3, 0, negative 1. So let's do the multiplication first. The order of operation, we still follow it. 6, 0, negative 2. And now we add them individually. So we have 2 plus 6, 8. Negative 4 plus 0, negative 4. 1 plus negative 2, negative 1. And we solved it. Magnitude and unit vectors. So this, now we are in 3D, but the same thing that we learned in 2D applies. So now PQ, it's going, if you have P of coordinates x1, y1, z1, and Q of x2, y2, z2, PQ is x2 minus x1, y2 minus y1, z2 minus z1, and to find the magnitude or the length, we use the distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So let's solve a problem. Consider the following points, P of coordinates 1, 5, 0, and Q 3, 11, 2. Find PQ and write your answer as ABC and AI plus BJ plus CK, so using the unit vectors. So PQ, vector PQ, is equal to 3 minus 1, 11 minus 5, 2 minus 0. So it's 2, 6, 2. And the second format, 2i plus 6j plus 2k. So remember how we, it's very important to write these arrows to emphasize that you are actually you are using vectors. B, find the magnitude of PQ. So PQ and magnitude is written like this. So it's going to be square root of 2 squared plus 6 squared plus 2 squared. So it is equal to 4 plus 36 plus 4. So it's square root of 44 or 2 square root of 11. And then part C is find two unit vectors parallel to PQ. So a unit vector can be written like this, U over absolute value of U. This is a unit vector. So a unit vector, writing PQ as a unit vector would be PQ over the magnitude of PQ, so it would be 262 over 2 square root of 11. So we have 1 over square root of 11, 3 over square root of 11, and 1 over square root of 11. This would be a unit vector. If you want to check it, you can just square each of them, add them together, and you're gonna get 1, right? That's the whole idea. The magnitude is 1, so we get 1 over 11 plus 9 over 11 plus 1 over 11. That's exactly 11 over 11. But we want 2 unit vectors, so another one, it would be if we put negative in front of the terms. So I'm going to put negative in front of each of them, or opposite of each of the terms. So this would be another unit vector that is parallel to PQ. And let's solve another problem. We have an airplane. It's flying horizontally due north. At 300 miles per hour when it encounters a horizontal crosswind blowing east at 40 miles per hour and a downdraft blowing vertical downwards at 10 miles per hour. Find the position vector that represents the velocity of the plane relative to the ground, and find the speed of the plane relative to the ground. So let's mark this as, would be east, this would be north, and this would be the z coordinate. So it's still x or y, but let's mark them as east and north here, to be able to write down what we have. So an airplane flying horizontally due north at 300 miles per hour. So this would be 300 miles per hour. So this would be the speed, let's call it v. It's 300 miles per hour. When it encounters a horizontal crosswind blowing east, so this would be a 40 miles per hour. So this is 300 miles per hour. This would be 40 miles per hour. And a downdraft blowing vertically at 10 miles per hour. So this would be this way, 10 miles per hour. Find the position vector that represents the velocity relative to the ground. So what else we have? We have the velocity of the crosswind. I'm just going to write VC, 40 miles per hour. And I'm going to say that V of the downdraft is 10 miles per hour. But if I want to write these as vectors, I'm going to say the velocity of the airplane, this one, can be written as let's say V is 300 J, right? Because this is I, J, and K, the unit vectors of the axis. Then VC would be, let's write better, these ones are the magnitudes. So the vectors are VC is 40I, there is nothing else for J and K, and this VD would be negative 10K. So V, the velocity of the plane, would be relative to the ground, let's say relative to the ground, would be V, the velocity that it's flying horizontally, plus VC plus VD. So it's the crosswind and it's the downward or downdraft velocity. So it's going to be 40I plus 300J minus 10K. So velocity relative to the ground. And B, the speed. So we want to find the magnitude of Vg, so that would be square root of 40 squared plus 300 squared plus negative 10 squared, which is square root of 1600 plus 90,000 plus 100. So that is equal to square root of 91,700, which is 302.8 miles per hour.